Hello everyone, welcome back. Today we will discuss about VLANs. So in this video I will cover what is VLAN, why we use VLANs, and also I will show how to configure VLANs on the network devices. So to understand the VLANs, we need to know what is LAN and broadcast domains. So in earlier videos I already said that LAN is a local area network which connects a group of devices like computers, routers, switches in a single location like home, office, etc. On more specific definition, I would say LAN is a single broadcast domain. I will explain here why we call LAN as a single broadcast domain. So here we have multiple PCs which are connected to the switch, and then switch connecting to the router, and then router will connect to the another network. So up to this router we will call this one as a LAN. So now we are calling it as a single broadcast domain. So here the PC wants to send a traffic to the PC in the HR department. So this PC doesn't know the destination address, so it starts to build the frame. That frame is called the broadcast frame. So it will send that packet to the switch. So whenever the switch receives the broadcast frame, it will flex that frame to all the devices except the port where on which the traffic is received. So here the switch receiving traffic from this port. So except to this port, the switch will flex the frame to all other ports. So all these are getting broadcast frames. And the router does not send the broadcast frame to another network. Because of this, we considered all these devices are under one broadcast domain, which is a LAN. So now I am reading out the broadcast domain definition. So broadcast domain is a group of devices which will receive broadcast frame sent by any one of the members. So here the switch is sending the broadcast frame, all other devices are getting it. So we will consider all these devices are in one broadcast domain. And then the problem with the broadcast domain is the switch floods the frame to all the ports relevant to the departments. Because of this, it creates a security problem and also the congestion because of the unnecessary broadcast traffic flow. To avoid this, we have a VLAN, which is Virtual Local Area Network. It is a way which segments the switch into multiple broadcast domain. So basically the virtual LAN will logically divides a physical network into multiple separate network. See here, even though the PCs in the different departments are connected to the same physical switch, when we enable VLAN, it allows you to segment the network. So the traffic is isolated between the departments. So generally the VLAN is like a virtual fence inside the network. It keeps traffic from different departments. And why we use VLANs? As I already said, VLAN is basically used for this to separate the traffic for the security and the management. And also it will increase the performance of the network because of the reduced broadcast traffic within each VLAN. And also we can assign we can group the users logically, not based on the physical location. And when we want to manage the users, it is easier for us to control and monitor the network because the users are divided into groups, so we can monitor based on the groups. Whenever the problem occurs, we can easily identify the root causes. And coming to the VLAN fundamentals, VLAN has an ID which is called VLAN ID. It is a unique number, starts from 1 to 4094 that identifies each VLAN on a switch. For example, VLAN 10 for HR, VLAN 20 for sales. And we have a few default VLANs, which is VLAN 1, 1002 to 1005, which are exist by default, but we will not use it on the devices and we cannot delete as well. And coming to the configuration, we need to enable VLANs on per interface. See here on the switch we enabled VLAN per interface. These two ports are considered as a financial VLAN. if we give the number, let's say VLAN 10 is for the financial, which is enabled on these two ports. VLAN 20 is for the sales, which is enabled on these two ports. Here we are enabling VLAN on interfaces of the switch. And then coming to the ports, VLAN has two different types of ports, which is access port and trunk port. Coming to the access port is a switch port that belongs to the single VLAN. Usually the access port connects to the end devices like PCs. See here, the PC here the switch connects the PC. Here we are having only single VLAN. It is not carrying any other VLANs. So we call this port as a access port. And coming to the trunk port, a switch port that carries traffic for multiple VLANs across a single physical link. So let's take an example of the connection between switch and the router. So let's assume there is a similar topology on the other side of the router and we assign different VLANs. So when we want to communicate with the other VLANs, this link has to carry the multiple VLANs. So that's why this port is called the trunk port. To carry the traffic between the VLANs, we need to add a .1 queue frame. In that we have a VLAN information. So based on that, whenever the switch receives the data, it will send to relevant VLAN based on the information. The VLAN information is like a VLAN ID. So for the inter-VLAN routing, we need a router or switch for the communication between the multiple VLANs. For that we have three methods, which is router with separate interface, router on a stick, layer 3 switch. So router with separate interface is nothing but we need to use separate physical link for each VLAN, which is not cost effective. So we will not use this one in the real world. And then coming to the router on a stick means it uses single physical router interface, but we will configure with multiple sub interfaces so that it can carry traffic for different VLAN via trunk link. So again, let's take the example of the connection between switch and the router. So here we have only single physical link, and on the router interface we will create a sub interface like .10, .20, .30 for each interfaces. So these sub interfaces will act as a separate interfaces for each VLAN. So it is simple and cost effective for small network, but it has several limitations like we are using only single physical interfaces, but it carrying multiple VLAN traffic. Whenever this physical interface fails, the communication between the inter-VLAN stops completely. And also because of this, all the traffic flows through the physical link, there will be bottleneck bandwidth. So it is limited to the only smaller network. We can't use it in the larger networks. And coming to the third one, which is layer 3 switch. So layer 3 inter-VLAN routing allows us different VLANs to communicate directly through layer 3 switch. So here we are using layer 2 switch, which doesn't know layer 2 activity like routing. That's why we are sending packet to the router, then the router will route the traffic to the PC. So in the router on a stick, how the packet was traveled from PC to switch to router, then again router to switch, and then switch to PC. To avoid this, we will use layer 3 switch here instead of this layer 2 switch, and also we will remove this router. So the layer 3 switch will perform routing functions internally by using switch virtual interfaces. It doesn't use any physical interfaces. We will create switch virtual interfaces so that they can carry multiple VLAN traffic between the devices. So here the switch virtual interface will act as a default gateway for all the devices in the VLAN. So let's consider this is a layer 3 VLAN. So here we will create a SVIs. So the default gateway for the this VLAN is the SVI which we created here. So the routing will happen inside the switch hardware. So that's the basic idea about the VLAN. So next we will next I will show how to configure it on the network devices. In this lab I will show how to assign VLANs to the switch interface, and then we will enable inter-VLAN routing. Here I already assigned IP addresses and host names to the devices. So now let's see what are the VLANs are existing on the devices. So enable command show VLAN brief. This command will show how many VLANs are existing on the switch. So as in the earlier I already said that one VLAN 1000 to 2005 VLANs are existing by default. We can't delete all those VLANs, and also we will not use on devices. So by default all the interfaces are assigned to VLAN 1. Now we will assign different VLANs to the different interfaces. Let's start with assigning access port to the switches which are connected to the end devices. So here I am assigning VLAN 10 to the financial departments on the interface F02 and F03. So conf t, let's go to configuration mode by command conf t, config t, interface range. So when we are assigning same command on the both interfaces, then we can use a word range so that we can assign both at a time. Interface range fast Ethernet 0223, switch port mode access, switch port access VLAN 10. See here, by default we have only 1 and 1002 to 1005. We don't have VLAN 10. We didn't create. But after assigning VLAN 10 to the interface, it was automatically created on the switch. Next, moving to next interfaces. Interface range fast Ethernet 0425. Switch port mode access. Switch port access. VLAN 20. So here I am assigning VLAN 20 to the HR department on the ports F04 and F05. So VLAN 20 is created, and then interface range fast Ethernet 0627. Switch port mode access. Switch port access VLAN 30. So VLAN 30 created and was assigned to F06 and F07. Then check the VLANs by command do show VLAN brief. See here, VLANs were created and assigned to the respective interfaces. Now give the names to VLANs. VLAN 10 name financial. VLAN 20 name HR. VLAN 30 name sales. Again check the command do show VLAN brief. See here, names also assigned. Now we will ping from the PC which is in financial department to PC in the HR department. Go to desktop and command prompt ping 10.10.30.11. See here, it is not able to reach the other side of the PC. Now we will enable inter-VLAN routing. For that, we need to enable F01 interface on the switch as a trunk port, and then we need to configure sub interfaces on the router. Here we are enabling inter-VLAN routing by using ROAS, which is router on a stick. See here, it seems like the router is sitting on the stick. So that's why it is called as router on a stick. The placement is like this, and then go to switch interface fast Ethernet 01 switch port mode trunk. So for the access port, we configured as switch port mode access. For the trunk, switch port mode trunk. So that's the configuration on the switch to enable trunk port. And then now go to router and command line. So enable. Now first we need to enable physical interface. So by default the router interfaces will be shut down, so we need to enable it by command no shutdown. So for that, configuration mode and then interface mode, interface gigabit 0/0/0 no shutdown. See here, the syslog command, the state to up, state was changed to up. Now create the sub interfaces. So interface gigabit 0/0/0.10. So here I am creating sub interface for the VLAN 10. So that's why .10 encapsulation .1q space 10. So here we can take different number as well, but for the easy identification I am taking the same number as VLAN number. I say an IP address 10.10.10.1, subnet mask 255.255.255.0, and then for VLAN 20, interface 0/0/0.20, encap. Here I am using shortcuts for the commands .1q space 20, IP address 10.10.20.1, subnet mask 255.255.255.4. So these address will act as a gateway for the irrespective of the VLANs. Next, for VLAN 30, interface 0/0/0.30, encap .1q space 30, IP address 10.10.30.1, subnet mask 255.255.255.4. So this is how we need to configure sub interfaces on the router. So each interface will act as a separate VLAN. So the IP address will act as a gateway for the respective devices in the VLANs. Now if the devices wants to connect to outside of the network, we need to configure default static route. This is how we need to do that. IP route o.o.o.o, and the next IP address as 203.0.11.2. Taking random IP address to show you how to configure the static default route. This is how we need to configure on the router. Now check and now save the configuration to write. So when we are configuring the commands, all those will be in the running configuration. When we save by the command do write, it will move to startup configuration, which will be saved permanently. Now check it. Go to command prompt, ping 10.10.30.11, See here, we are getting a reply from the 30.11. Now we can route the traffic between the different VLANs. This is how we need to enable inter-VLAN routing. And then let's see how to configure them. But this router on a stick is limited to smaller network designs only. So next I will show how to configure layer 3 for the inter-VLAN routing, layer 3 switch for the inter-VLAN routing, which is commonly used in the real world.